Hello friends, welcome to online lecture series. This is the sixth lecture of unit number 2, that is phase rule. Okay, so the main heading is 3 pair partially miscible liquids. 3 pair partially miscible liquids. So in our previous 2 lecture we discussed about 1 pair partially miscible liquids and 2 pair partially miscible liquids. Okay, so here 3 pair, it means suppose I take 3 liquid solution, capital A, capital B and capital C, in which capital A and capital B, capital A and capital C and capital B and capital C. These 3 pairs, it means these 3 pairs are partially miscible with each other. Okay, so here 3 partially miscible liquids are formed. First one is AB, second one is AC and last one is BC. Okay, so here in this case 3 binodal curve are obtained. Pair A and B, it means liquid A and B is partially miscible with each other. Liquid A and C is also partially miscible with each other, and liquid B and C is also partially miscible with each other. Okay, so it forms 3 partially miscible liquid pair. First one is AB, AC and BC. Okay, so this is the main heading is 3 pair partially miscible liquids. So consider 3 liquids, capital A, capital B and capital C, and that are partially miscible in each other. So 3 binodal curves, first one is ADB, second one is CEFD and last one is small e capital EF. Okay, so ADB, CFD and small e capital EF with 3 plate point. First one is plate point, first plate point is capital D, second is F and last one is E. Okay, so 3 plate points D, F and E respectively are obtained. So in this case 3 pairs are partially miscible with each other. It means 3 binodal curve and 3 plate points are obtained. Okay, so what do you mean by binodal curve? Binodal curve separate 2 phases. First one is heterogeneous and second one is homogeneous. So binodal curve is a boundary. Boundary means it is separate 2 different phases, homogeneous and heterogeneous. Okay, so first one binodal curve ADB, second CEFD and last one E, small e capital EF. Okay, so 8 point within the binodal curve, 8 point within the binodal curve system becomes heterogeneous, and outside of the binodal curve system becomes homogeneous. It means inside the binodal curve, here we can see that this is for capital A and capital B. This binodal curve is obtained on side capital A and capital B. So capital A and capital B is partially miscible with each other. Okay, so it forms heterogeneous system. Partially miscible means some amount of A and B is dissolved while another amount is remain as it is. So it forms heterogeneous system. Okay, so for heterogeneous system, it means system becomes heterogeneous inside the binodal curve, but while outside the binodal curve system becomes homogeneous. Okay, so 8 point within the binodal curve gives heterogeneous system, and outside of these 3 binodal curve, it means this area indicates the system is homogeneous. Okay, system outside of this binodal curve 3 components are completely miscible and it gives homogeneous system. It means inside the binodal curve 2 components are not completely mixed. It means it is immiscible within the binodal curve, but outside the binodal curve all the components are completely miscible and form only one phase. Okay, so at lower temperature, same in our previous lecture, 2 pair partially miscible liquids, if temperature are lower, at that time the miscibility power is also decreases. Okay, if temperature is lower, if I decrease the temperature, at that time miscibility power is decreases. Okay, so all the 3 binodal curves are broadened out and convert into only one binodal curve. Okay, so this indicates when temperature is decreased, it means at low temperature. Okay, so at lower temperature binodal curve broaden out and overlap into one another. At lower temperature all the binodal curve broaden out and overlap to one another, as shown in figure, due to decrease in miscibility. Okay, so at lower temperature miscibility power is decreases, or mixing power. Miscibility power means mixing power. Okay, so if you add sugar in hot water, then sugar is easily dissolved in hot water. While if you add sugar in cold water, at that time it is not completely mixed easily. It means miscibility power decreases when temperature is decreases. Okay, so at low temperature, all the three binodal curve are broaden out and convert into one another. Okay, and overlap into one another, and at that time three different points are arise. First one is 1 1 1, second one is this 2 2 2, and last one is 3. Okay, so at that time three different situations are arise. Okay, so first one, 8 point within the area marked as A1, sorry. So 8.1, here also 1 and here also 1. So 8 point marked as 1, it means it form homogeneous system. Homogeneous means all the three components are completely dissolved. 8.1 here, here and here also. Okay, so 8 point within the area marked as 1 gives homogeneous system with one phase. Okay, so if A, B, C all are they completely mixed together at that time, it forms homogeneous system, and for homogeneous system phase is equal to 1. Okay, so according to Gibbs phase rule, F is equal to C minus P plus 2. Here components are 3. 1, 2 and 3. Components are 3. So 3 plus 2 is equal to 5. 3 plus 2 is equal to 5 minus P. Okay, so here marked area within the marked A1, it means it indicates homogeneous system, and for homogeneous system phase is equal to 1. Okay, so 5 minus 1 is equal to 4. So for area within the marked 1, it means it here the value of F is equal to 4. It means F means degree of freedom. F means degree of freedom is equal to 4. It means four variables are changes within the mark area 1. Okay, so now at any point 2 within the marked area 2, it means here 2 2 2. Okay, so it indicates the system is heterogeneous. Same here. Inside the binodal curve, system becomes heterogeneous, while outside of this binodal curve, system becomes homogeneous. Okay, so at that point marked as 2, here we can see that two phases are arise. 2. It means it is first one is not completely miscible or completely homogeneous mixture. Okay, so the value of phase is equal to 2 here. Here the value of phase is equal to 1. Okay, so for area 2, here, here and here, these three area, first one is according to Gibbs phase rule, F is equal to C minus P plus 2. So it is the equation of Gibbs phase rule. Gibbs phase rule gives a relationship between degree of freedom, components and phases. Okay, so F is equal to C minus P plus 2. Here C means components. Different components are given. So 3 plus 2 is equal to 5 minus P. Okay, so here within the area marked 2, it means system becomes heterogeneous. So the value of the phases is equal to 2. Two different phases are arrived inside the area marked as 2. Okay, so 5 minus P, 3 plus 2 is equal to 5. 5 minus P, here phases are 2. So the value of F is equal to 3. F is equal to 3 in area marked as 2. Okay, and same as for area marked as 3, it means any point within the area marked as 3 gives 3 liquid layer. It means here in this case, first one is, this is also heterogeneous system, so the value of phases are, it means in this case all the three components A, B, C, all the three components A plus B plus C gives heterogeneous system, while area marked as 2, it gives heterogeneous but components are 2. Here this area indicates same as here. This area indicates capital A and capital B is immiscible. Capital A and capital B immiscible liquid. It means heterogeneous system of A and B. This area indicates heterogeneous system of B and C, and this area indicates heterogeneous system of A and C. Okay, So here marked is area 3, it means it decrease in temperature. These three binodal curve are broaden out and convert into overlap into one another. Okay, so at area 3, three different components are gives heterogeneous system. So the value of phases P is equal to 3. Okay, here the phases value of phases P is equal to 2 because these two components miscible liquids form miscible liquids at point inside the binodal curve. Okay, so in region 3 marked as 3 gives 3 liquid layers. So for that the degree of freedom F is equal to C minus P plus 2. So 3 plus 2, 3 components are given, 3 plus 2 is equal to 5 minus P. Here the value of phases P is equal to 3. So 5 minus 3 is equal to 2. Here the value of phases is equal to 3, but degree of freedom F is equal to 2. Okay, so in region 3 only two variables can vary with without disturbance number of phases. It means when area 3 is in equilibrium, at that time two different variables, at that time two variables means thermodynamics variables like temperature, volume, concentration, pressure, moles. Okay, so two variables can vary means changes, vary without disturbance number of phases. Okay, so this is the all explanation of three phase system. Okay, and examples of three phase system is first one is succinic nitrile plus water plus ether. Succinic nitrile, water and ether gives three phase system. Okay, so in this case not any two are completely mixed. Succinic nitrile is not mixed with water completely, and succinic nitride is also form heterogeneous solution with ether. Okay, so in this case all the three pairs are immiscible. Okay, so it form three different binodal curves. So at lower temperature three different binodal curve broaden out and overlap into one another. Okay, so first heading is three pair partially miscible liquid. So we consider three liquids A, B, C, and which all the three pairs of liquid, first one is A and B, second one is B and A and C, and last one is B and C. All the three pairs of liquids are partially miscible with one another. Okay, so consider three liquid A, B, C that are partially miscible in one another. Three binodal curve are obtained. Inside the binodal curve system becomes heterogeneous, while outside of this binodal curve system becomes homogeneous. Okay, so at decreasing temperature, while decreasing temperature, it means three binodal curve broaden out and overlap into one another, and at that time this area 3 is obtained. This area 3 is obtained. Okay, so at point within the binodal curve system becomes heterogeneous, outside of the binodal curve system becomes homogeneous. So at lower temperature the binodal curve are broaden out and convert into one another, and at point marked 1, here phase is equal to 1, completely homogeneous system. Here phase is equal to 2, heterogeneous system. Component is A and C, here component is B and C, here component is A and B. But it marked area 3, this area indicates heterogeneous system, but phases are 3, A, B and C. 3 phases are possible in this case. Okay, so the value of P is equal to 3. So for marked area 1, the value of degree of freedom is equal to 4. For marked area 2, the value of degree of freedom is equal to 3. And for marked area 3, the value of degree of freedom is equal to 2. Okay, so this is the basic example of three pair system. First one is succinic nitride plus water plus ether. Okay, so this is the basic explanation of three pair system. All the three theories are same. All the three theory, first one is one pair, second one is two pair, and last one is three pair. All the theory explanation of all the theories are same. So I request to you, first complete one phase system, then after two phase system, then after you can easily write about two pair and three pair system. Okay, so main point is this is the timeline, this is the critical point or plate point, and this is the binodal curve. Binodal curve separate two different system, it means homogeneous and heterogeneous. Okay, so when temperature is decreased, at that time binodal curve broaden out and convert into overlap into one another and convert another shape. Okay, so this all explanation are same in these three theories. First one is one phase, second one is two phase, and last one is three phase. Okay, so all the theories are most important and asked in university exam with 5 marks. Okay, so all these three theory contain 5 marks in your university exam. Okay, so I completed here lecture number 6 and also phase rule. And also phase rule, it means chemistry 503 paper, unit number 2, phase rule. So phase rule contain only 6 lecture because this is a small chapter and it contains only main 3 theories, 1 pair, 2 pair and 3 pair, and some basic definition like phase, components, constituents, degree of freedom. Okay, so for definition and 3 theory contain all this chapter. For definition, first one is phase, second one is constituent, last one is degree of freedom and components. For definition and 3 main theories, 1 pair, 2 pair and 3 pair. Okay, so I completed phase rule in lecture number 6. Okay, so thank you for watching this video.